So we are going to learn about how to solve homogeneous linear higher order differential equations in chapter 4. But we have to lay a foundation. So we are going to lay it here. Okay. So before that we have to recall what is homogeneous means. Look at equation 4 and 5. Which one is the homogeneous equation and which one is the non-homogeneous one? Well, equation 4 is the homogeneous one, equation 5 is the non-homogeneous one. We already learned it in chapter 4 how to decide homogeneity and non-homogeneity. So I'm not going to go into deep discussion in this video, but let's try to learn a lifesaver so that we can continue our chapter without a problem. Okay, just enough for our chapter. Okay, so basically what is the difference between 4 and 5 equation? Well, in the equation 4 you have 0 on the right hand side, equation 5 you have gx on the right hand side. So that's what decides the homogeneity. Now gx is like that isolated function, right? We call it the isolated function. It's neither a coefficient of y or its derivatives, right? So what is this gx represent? So it's like an external force. Think about a pendulum. So if you let a pendulum be like itself without external push or wind, it will have some small oscillation, a free oscillation by itself. We can model it by a homogeneous differential equation. Okay, but if you give a little push, then there will be more oscillation because of that external force. Now we can model the scenario where the external force is represented by G. Okay, so that's a non-homogeneous differential equation. You can think about a metal ball. You have a metal ball in your room and it will have a heat distribution according to the room temperature. Then you can model it by a homogeneous equation. But if you put a flame, if you give a external heat source to the metal ball, it will have a new heat distribution based on that external heat source. Then it can be represented by that non-homogeneous differential equation. So it's like an external force that drives the system. That's a non-homogeneous differential equation. That external force is the non-homogeneity. Okay, or in simply, if you have 0 on the right hand side, that's a homogeneous differential equation. If you have a non-zero function on the right hand side, that's a non-homogeneous differential equation. Just it is enough to survive this chapter. Okay, all right, but we discussed the bigger idea in chapter 1. Now how do we solve a homogeneous differential equation? Here's how we solve it. Solving a homogeneous linear higher order differential equation is like solving a jigsaw puzzle. Now how do you solve a jigsaw puzzle? At the end of the day, you want that big, nice, beautiful picture or pattern to be displayed in the jigsaw puzzle. So you have to connect the correct pieces of the jigsaw puzzle. You have to find the correct pieces and the place to put it. Exactly, we do the same when we are solving a homogeneous differential equation. So we have to find the pieces. Okay, so you have a big solution just like the jigsaw puzzle. You have to find the correct pieces of solutions and you combine them, you get that final solution. Okay, do you understand the idea that I'm getting it? Okay, so let's discuss it from an example. Okay, before going to that, all right, so to solve a jigsaw puzzle, you must have a certain number of pieces, right? So they might give you 100 pieces that is misplaced in several places. Okay, so then you have to find it. But if a jigsaw puzzle need 100 pieces, okay, to complete, but if you only have 90, you're never going to complete it, right? Same in homogeneous differential equation. How many solution pieces you want to find? That's the question. So the solution number of solution pieces is equal to the order. Okay, so if you have a second order differential equation, you need 2 pieces of solutions. Third order differential equation, you need 3 pieces of solutions. Fourth order differential equation, you need 4 pieces of solutions. Okay, so it's not a good way to say that, it's not good to say that solution pieces, but for the sake of understanding, let's use that word. Okay, and on the other hand side, they have to be correct pieces. What do I mean? We are going to learn that in next video, but let's look at an example. Okay, look at this second order homogeneous differential equation. See, we have 0 on the right hand side, so homogeneous. And so this is second order. So how many pieces you need? We need 2 pieces. Look at what it says. For the differential equation on an interval here, x cube and x4 are both solutions. Okay, so we have 2 pieces, right? y1 x to the cube is also a solution, y2 x to the 4 is also a solution. So solution means it satisfies the differential equation. Okay, now there's an interesting theorem. Here's the part. The theorem here, superposition principle, okay, we call it the superposition principle. It says, so you have these 2 pieces of solutions, right? Okay, let me tell you something. Combine them in a linear manner. Take the linear combination of them. That means multiply x cube by a constant, multiply x4 by a constant and add them. That is also a solution of the same differential equation. Interesting, right? Okay, so let me show you. What do I mean? So let's add them. X cube plus x4. This is also a solution of the same differential equation. Alright, 1000 times x cube plus x to the 4. This is also a solution of the same differential equation, because you just multiply x cube by a constant and add to x to the 4. Let's construct another one. 2 times x cube minus 4 times x to the 4. This is also a solution of the same differential equation. Right? Very interesting, right? Well, you can find infinitely many solutions right here. Okay, so you have lots of solutions. How to find the correct one big solution? Okay, so how to find it? Here's the idea. You find these correct pieces. Okay, what do I mean by correct? Let's discuss on it on the next video. But you find these pieces, take the linear combination. So y is equal to c1 x cube plus c2 x to the 4. Okay, so there are infinitely many solutions here, because you can choose any number you like for c1 and c2. This we call a what kind of a solution? A general solution for the homogeneous differential equation. Okay, just like we had general solutions in previous chapters, but now we are working with higher order. In previous chapters we learned first order differential equation, so we only had a one piece and it contained an arbitrary constant. That's it. But now when you are working with second order differential equation, you will have small pieces of solutions, just like x cube and x4 here. Now you combine them using constant, arbitrary constants. That is the one big solution. So you don't write this infinitely many solution list like I did. You just say this is the general solution, and we have a name for it. Let's learn it later, but that's the idea. Okay, so to get this general representation, you have to find the correct pieces. What do I mean? Now here's a cool thing. X cube is a solution. So does that mean 1000 times x cube is a solution of the same differential equation? Think about it. What do you think? X cube is a solution. Is 1000 times x cube a solution? Yes, of course. Right? It's the same thing. It's just a constant multiple of x cube. It will also be a solution of the same differential equation. That is what sort of we already said here. Right? So any constant times x cube is also a solution of the differential equation. Any constant times x to the 4 is also a solution of the example differential equation that I gave. So someone can say, well, you know, my 2 solutions are x cube, 2 solution pieces are x cube and 1000 x cube. Is that correct? Now you're gonna say your general solution is c1 x cube plus c2 x cube, 1000 x cube. That's not correct, right? That is not correct, because you are missing that different solution, right? X to the 4 is different from x to the cube, right? So you forget that, you misplace that, you don't use it. So that's what I meant. You have to find the correct pieces. You have to find this x cube and x4, the distinct solutions. Okay, but if you say x cube and 1000 x cube, that's the same copy of the same jigsaw puzzle piece. You cannot photocopy a jigsaw puzzle piece and try to complete the whole jigsaw puzzle. You have to find the distinct different jigsaw puzzle pieces and connect them just like here. So that is what I said, the correct pieces. Okay, so how do we find them? What are the leads to find them? We're going to learn that in the next video. So what is the big takeaway in this video? When you have a homogeneous linear differential equation, find those pieces of solutions. So number of pieces you should have should be equal to the order. You combine them in a linear manner, and that's your general solution for the homogeneous linear differential equation. I'll see you in the next video. Okay.